In this video, I'm going to be looking at this little gadget. So it's a logic analyzer that I bought from AliExpress. It's an 8-channel, 24 megahertz device. And I'm going to say right out the bat, probably the best thing I've bought all year on AliExpress. Absolutely amazing what it can do. And look at the price of it. It's almost free. It's a no-brainer. I can't believe I've gone so long without having one of these devices. Every time I've struggled with like an I2C sensor or some kind of communication with a microprocessor, this little device would have solved those problems so much quicker. That's what I'm going to be looking at in this video, and I'm going to set it up with some free software and show you how you can actually probe an I2C bus. So stay tuned. Let's have a look. You get the logic analyzer, which is just this little black case. It's got the old style USB-B connector, I think it is, and it's got this, 10-pin connector. Comes with some wires, so it comes with the USB-B cable, which is fortunate because I don't really have one. And it comes with a set of wires, so you can connect it to your sensors or your microprocessor. I have no idea what software this uses. I'm going to go try and plug it in. Okay, there's a red light came on. Don't know if you can quite see that. But that's it. Nothing's flashed up. I didn't expect it to. Now I have to do some Googling to try and find the relevant software. This is where the fun began. So basically, there's so little information on this particular AliExpress page that I looked at some other advert. They're all the same unit. They're just different prices, to be honest. So I didn't expect any difference in hardware. And I found a page that mentioned a piece of software called Pulseview. It's free. It looks pretty good. I went to the Pulseview website, and of course, it's no longer available. This caused me massive problems. A lot of Googling later, I basically found a GitHub repository where there's the Pulseview executable for Windows and various other operating systems as well. I managed to get the software, install the drivers, and I was up and running. But it was by no means an easy thing to do. It took me quite a while to figure out exactly what needed to be done. Probably won't go through all that in this video, but what I'll do is I'll probably make a follow-up video specifically on how to set up this particular logic analyzer, because I think it's worth going through it in detail. So once I've done all that, the analyzer's up and running, ready to start looking at various digital communications. So to test this, I'm going to set up a really simple circuit. So I've got a little ESP32 C3 mini. I've got a BME 280 breakout board. So this is basically a temperature and humidity sensor. You can see it's an I2C, it's got an SCL, SDA and a ground, and 3.3 volts. So I'm going to smash that into here, and I'm going to get this wired up. So all I'm going to do is open up the I2C scanner. So this is basically an included sketch that looks at the I2C bus and looks to see if there's any addresses. And all I need to change on this default sketch is to put, I think it's SDA first and then the SCL. Oh, it tells you there, look, so SDA pin first and SCL pin second. So that's what I've done. Let me upload this sketch. Okay, open the serial monitor. I2C device found at address 76. Okay, so we can see it's communicating via the I2C bus and it's getting the address of the chip. Let me just disconnect it and then I'll connect the logic analyzer. The black wire is my ground. The white wire is I can't remember what, but it doesn't really matter for now. And the grey wire is going to go into this one. Okay, let's plug it back in. So I'm going to do a few little things. I'm going to increase the sample rate, maybe 5 meg, sample frequency, let's say 2 megahertz. Now if I press this, should see some data. Part of the problem is catching the actual request. There you go. So you can see that's all the data. It looks like D1 is the clock, D0 is the actual data. What I really like about Pulseview is that if you click here, it's got all these different decoders. So if you're interested in CAN buses, you can look at automotive, audio, I2S, MIDI. It's absolutely amazing for a free piece of software. This is so powerful. I want I2C, add that. And then what did we say? D1 was the clock. So serial clock line D1, serial data line D0. And there we go. Basically what this sketch does is it sends all these addresses and it waits for a response. So basically it starts, it loads that address in, it writes it, and then there's a return of no acknowledge. Okay, so this is address 01. Let's zoom out. Look here, we can see something slightly different. We already saw in the serial terminal that we're on address 76. And if you look at here, we've got start, address write, 76, write, acknowledge. So we know that's the only one that's got an acknowledge. All the others have got no acknowledge. So we can see we're successfully looking at the I2C bus just from that little example. So everything's working there. Let's try and get some data from this. Well, this is the example sketch that comes with that library. I need to change this to be wire begin 10. Let's smash that on and see what happens. So if you look at the screen now, we're getting some data. Let's have a look at how that looks on the logic analyzer. So here we're sending data writes to address 76. And then, so we send various commands and then we do various reads. So you can see the numbers are different. Once we have the data, how do we actually check that it's working as it should? Well, to do that, we really need the data sheet. We found the data sheet for this BME 280, and there's a section on I2C interface. And if we look at it, it basically tells us what we need to do. Look, if we're going to do a write, writing is done by sending the slave address. Then the master sends pairs of register addresses and register data. So basically, this is the address, this is the register we want to write to, and that's the data we're going to write. Let's have a look now in Pulseview. Is that what we get? So let's zoom in into one of these. So here we're going to start. There's the address, there's the write, this is the acknowledge, this is the register we want to write to, F4, and we get an acknowledge, and then we send the data, 25, acknowledge. And again, if we look at the read here, exactly the same thing. We send the address, we get an acknowledge, and then we read the data, blah, 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 blah. You see the values are slightly different, but it's always the same structure. And if you were actually trying to do this and there was something wrong, you would probably see here that, you might be writing to the wrong register, or you might not be getting an acknowledgement. So that's it. I mean, that's an incredibly powerful device and functionality for really such little cost. Let's just try one more experiment on a different protocol. What I have here is one of those Dallas semiconductors, one wire temperature probes. It looks like one of those little old-fashioned transistors, but it isn't. It's actually a temperature probe, and it needs a resistor, which is actually in this heat shrink. So I don't know why I was using this, using it to measure the temperature on something. Let me just stick these in here. So that's the data line. Well, I hope these are right. That's the ground, and that's the 3.3 volts. So I don't need all these wires anymore, just need one wire. So 3.3 volts, brown one is the ground, and the orange one on D0 is my one wire communication. Okay, so simple as that. I'm gonna plug that in. Let me capture some fresh data, and it's a little bit more complicated. So how to interpret all that? Well, I'll show you a trick. You can save all this. You can go into ChatGPT, you can smash the data in.
A few moments later.
It's saying the temperature is 24.125, and if you look in Arduino, a serial terminal, I've unplugged it now, but it was reading 24. This probably rounds it up or something. I don't know what the Arduino is actually doing, but I actually trust that from the raw data that we got 24. So that's pretty cool. It took a long time though. It took 3 minutes to work that out. But just shows you that it does work, and it's not just for I2C. But just to quickly wrap up this video, pick one of these up is my advice. They're absolutely amazing. I can't believe I've gone so long without actually getting one. If you're trying to interface sensors or anything else to a microprocessor, this is the diagnostic tool you need to find those faults, to debug it when things don't work. And it's absolutely amazing. For the price, around $1, you just can't get better. It's definitely the most impressive thing I've bought from AliExpress. So with that, I'm going to end the video. If you've got any comments, please put them down below. I'm really interested to hear if you've used one of these and how you found it. Thanks for watching. And if you enjoyed this video, please like and subscribe because it really helps the channel. See you in the next one.